So, good morning, class, and welcome to your Management Science course. Today, we'll discuss about integer programming. And also, during the discussion, we'll try to have a little review of your linear programming because basically integer programming is similar to your linear programming. No? So, remember during the discussion on linear programming, I taught you how to um, it's a procedural step to go through the profit maximization using linear programming as a decision tool. No? So, like I said, it's similar with integer programming. It's just that in integer programming, we're dealing with integers, and of course, to better understand the concept, we'll also need to define what is an integer. No? But that's very basic for you. One of the learning objective here uh, is also to demonstrate the integer programming using the Microsoft Excel as a tool. Uh, Basically, class, integer programming is more of an engineering course rather than accounting. No? So that's why the approach that we're going to undertake as well is more of a procedural step, a bit of analysis, of course. And just imagine yourself being an auditor or providing a management advisory services to an engineering firm um, or essentially for someone who would like to invest and who has uh, decision constraints. No? So there's a limitation in the resource, or there's a limitation in terms of the uh, decision variables. No? So we'll discuss all of that later. And also we'll tackle the three basic types of integer programming. It's going to be an exciting um, quantitative decision tool. But like we said, since we have already completed our discussion of linear programming, so it should be fairly easy to you. So first, let's define what is an integer. No? An integer is a whole number, a number that is not a fraction. So imagine you have uh, you have to decide whether to buy land or funds or condominium unit. No? So with integer programming, of course, we have to define it as a whole number, no? Because essentially, you can't buy. I want to buy one condo unit and one fort. No? So we can't do that. No? That's why. That's the only difference of linear programming with or integer programming with linear programming. So in integer programming, we're dealing with whole numbers. No? So not a fraction of a number. So a thing complete in itself. Like I said, there are three integer programming models. So number one, we have the total integer model. So all the decision variables are required to have integer solution values. So meaning to say, uh, all the factors or all the decision constraints would need to give us a whole number. Then number two, we have the 0 to 1 integer model. All the decision variables have integer values of 0, either 0 or 1. And the third is the mixed integer model. So some of the decision variables, but not all, are required to have integer solutions. So meaning um, it's a combination of integer and non-integer values, not to say. All right. So I prepared here three problems. No? First, we have the problem on total integer model, and then 0 to 1 integer model, and finally on the mixed integer model. No? But I have to share my screen for the Excel file. So let's do let's do it one model at a time. So let's have the total integer model example. The owner of a machine shop is planning to expand by purchasing some new machines, presses, and lathes. The owner has estimated that each press purchase will increase profit by 100 pesos per day, and each lathe will increase profit by 150 pesos daily. The number of machines the owner can purchase is limited by the cost of the machines and the available floor space in the shop. The machine purchase prices and space requirements are as follows. So for press, it requires 15 feet floor space and has a purchase price of 8,000 pesos per machine. And for that, we have, it requires 30 feet floor space, and it has a purchase price of 4,000 pesos per machine. The owner has a budget of 40,000 pesos for purchasing machines and 200 square feet of available floor space. The owner wants to know how many of each type of machine to purchase to maximize the daily increase in profit. Again, this is a classic example of decision making, no? Especially for us as management accountants. We are dealing with a situation where, yes, we have a budget. Uh, Now, because of the constraints, we have to identify what's the perfect mix, no, to maximize our profit on daily basis. So let's take this an example, and let me share my uh, screen. Let's go to the Excel file. Right, so let's have, so here's the problem, no? So at least just for us to uh, be familiar with the problem in itself, this is the press machine, no? And this is the lat. Actually, the lat is being used to reshape, no? So reshape steel, no? Like if you want it to be curved, no? So you will use the lat machine. So at least we have an idea now. So basically the problem would like to uh, have us determine the profit, no? To maximize the profit, but with the additional purchase of machines, no? Press and lathe, right? So again, in linear programming, we have already discussed this, no? So we express the profit as Z, no? So Z is equals to 100x. 100 is the daily profit per day of press, no? So let X be your number of presses, and then Y is the number of lats, no? Or the lats machine. So that's 100x and plus 150y. And this is the profit maximization equation. Like this. So let me just highlight it. And of course, this profit maximization is subject to decision constraints. And number one is on the budget, no? So how much budget do we have? So that's only 40,000 pesos. And now, uh, it's subject also to the purchase price of press, no? So the purchase price of press is 8,000. So that's let's express it as 8,000x. So 8,000 for machine press and 4,000 pesos for machine Y. So that's for 8,000x plus 4,000y is less than or equal to 40,000 pesos. Now, it's also subject to another decision constraint, no? Which relates now to the floor space. No? So, of course, floor area. It's mentioned in the problem that uh, there's only 200 square feet of available floor space. No? So imagine even the floor space is a constraint, no? In this given example. So for each machine press, it requires 15 floor space and 30 for lat. No? So that's 15x plus 30y is equal or less than to 200 feet squared. Now, since we're talking of machines, of course, we have to express it as either as zero or an integer, no? So it should be a whole number, no? Because we can purchase like one and a half press machines, or 1 3/4 lat of flat machine. No? So we can't do that. But this is why we have also to uh, express it as x or y is greater than 0 and integer, meaning this needs to be a whole number, right? So actually this part is not new to you. This is exactly what we've done when we discussed the linear programming. So you can, if you would like, you can just go and revisit that video recording on the linear programming, so that you'll be um, uh, you can review it, no, for this purpose. I think the only difference here is this constraint, where we need to include these constraints on the integer, because like I said, this is integer programming. Now, in linear programming, I taught you how to calculate it manually. But manually, meaning we have used our algebraic expression to solve for x and y. No? But in this case, in integer programming, we'll introduce another method of calculating profit maximization. That's why earlier I mentioned to you that this is more of an engineering topic, no, rather than accounting. But of course, we have to know the basic concepts of it, no, in order for us to be a more effective accountant, no, to say the least. No? So I'll introduce to you the use of MS Excel and the use of solver feature of your Microsoft Excel. Now, if you basically the solver add-in is included in your data menu. But if in case it's not available there yet, all you need to do is just go to options and then add-ins, and then look for solver add-in, and then go to Excel add-ins go. Just have to click on the solver add-in and then hit OK. And then the solver add-in will automatically place in this part of the data menu. Okay, so what I did, of course, is just for the benefit of the presentation, I created this table, no? But in fact, this is similar with the constraints that we have identified earlier, no? But let me point this out once again. So of course, in this example, excuse me, in this example, we have two machines, the presses and the lat. And then of course we have the purchase price, and that's given naman. So we have 8,000 and 4,000 for press and lats respectively. And the floor space, no? So that's 15 and 30 for press and lat respectively. Now we have the resources, no? This one, the usage, no, later on I'll discuss how are we going to get this formula. But let's discuss first the resources here. Of course, in the purchase price, this one, no? Look at this one. We have this constraint, no? So we only have 40,000 pesos as our budget for the entire press and lats machines, no? So depending on the number of machines that we need to buy, we only have 40,000 pesos, no? And of course, there's also a constraint on the floor space, no? So floor space natin, we only have 200 feet square. 200 square feet available in our factory, no, to accommodate X and Y. No? So meaning to accommodate the number of presses and lattice machines to be purchased. So basically this portion, this only represent the constraints that we have already determined earlier on. So ayan lang naman siya. Now, how are we going to calculate or derive this formula? No? So basically, class, since in this part we're talking about the purchase price, so we only want to calculate the usage. No, so that's C6. So C6 is the purchase price for press, and then B6 is the purchase price for lat. No? And multiplied by B10. B10 is blank right now because later on when we use the solver add-in in the data menu, it will automatically populate. No? But basically this blank, I'll just highlight it in purple. This will reflect the number of presses and the number of lattice machines, last machines to be purchased to maximize the profit. No, remember class, the intention here is to determine the number of presses and lats to maximize the daily profit. No? So take note of that and don't forget that concept. No? All right, no? So right now it's 0 because we don't have the numbers here yet. No? Similar to the floor space, again, in floor space, we only have 200 square feet, no, available in our factory to accommodate both presses and last machines. So right now it's 0 because, again, the number of presses and last machines are not yet calculated in here, but we have completed the calculation, no? So that when we calculate the number of presses and lats here, it will automatically populate here. No? But basically the intention here is to calculate the number of floor space. No? So for press, it requires 15 square feet. And then for lat, it requires 30 square feet. No? So there you go. This is just the table of the constraints, no, class? So take time to absorb it first. All right. So we go now to the use of the uh, solver, no, in the data tab or data menu. Okay. So we go to data and then solver. So there are a number of fields here. First, we have set objective. Of course, in the set objective, the objective is to maximize. Ano? So we uh, input profit here. So that's B12. And then, so that's correct. No? So to max by changing variable cells. Now, what are the variable cells in this case, class? Sige na. Try to think for it first. Okay. So of course, the variable here would be your presses and lats. No? So the number of machines, no? Number of presses and the number of lats to be purchased. Now, let's go to the constraints. No? Of course, in here, we just have to click hit add. Add here. So cell reference would be your usage, and then the same, no? Parang kinocopy lang natin. We're just copying this from the Excel file to this table, no? or pop out. So that's less than or equal to constraints 40,000. All right. So add. There's also another constraint. So here, less than or equal to, you can put the number. I can type in 200 or simply just link it to the cell. I think that's easier to do. Now we have already these two constraints available. And then of course, we have to click make unconstrained variables non-negative. And then we have to choose simplex linear programming. Like I said, integer programming is similar with the linear programming. And then hit solve, click solve. No? So class, look at this. So it already provides us the number of presses and lats. No? However, like I said, this is integer, no? So we're dealing with whole numbers, no? So we can't buy, I'd like to buy 2.22 units of presses, no? We can't do that, no? So that's why for total integer, we have to do our rounding off, no? But in this case, we have to round down, no? Because the, well, instead of rounding up, we have to round the numbers down because of this. No, it's saying less than or equal to 40,000 and to 200. So in this case, so if we're going to round it down, that's 2. And then of course for that it's 5. So we need to purchase 2 presses, 2 units of presses, and 5 units of lats machines. No? So to maximize the profit at 950 pesos. No? So as you can see, there's a leftover here. We have 4,000 pesos left and 20 square feet left. No? But again, because of this, try to look at this, no? In fact, we still have 4,000 pesos left, which we can buy another unit of flat. However, take note that we only have 20 square feet of floor space, and therefore uh, it can no longer accommodate another unit of a lat machine. So I hope you get that. I will give you 1 minute to absorb the whole concept before we go to number 2. Right? Okay. We go now to problem number 2. So a 0 to 1 integer model uh, example. So a community council must decide which recreation facilities to construct in its community. 4 new recreational facilities have been proposed: a swimming pool, a tennis center, an athletic field, and a gymnasium. The council wants to construct facilities that will maximize the expected daily usage by the residents of the community, subject to land and cost limitations. The expected daily usage and costs and the land requirements for each facility follows. So we have the swimming pool, tennis center, athletic field, and gymnasium. And then here are the expected usage, no, people per day. So, and then we have the cost and then the land requirements. The community has 120,000 pesos construction budget and 12 acres of land. Because the swimming pool and tennis center must be built on the same parcel of land same part of the land parcel, However, only one of these two facilities can be constructed. No? So again, class, this is another example of constraint. No, imagine you have to decide whether you're going to build a swimming pool or a tennis center because there's only one space allocated, one parcel of land allocated for that particular facility. Now, the council wants to know which of the recreation facilities to construct to maximize expected daily usage. So again, this is another classic example of profit maximization. But right now, it's in terms of the number of expected daily usage. Of course, it will translate to profit eventually. No? So uh, let's try to create this. Let's discuss this formula over here. Now, of course, to express the profit, in this case, the maximum daily usage, let's express it like as Z. No? Z is equal to 300 W. So W is the construction of swimming pool. We have X as the tennis center, athletic field for Y, and Z for construction of gym. No? Let's put it this way, no, para at least, so that we won't be confused. No? Okay, so uh, so we have 300 W, 90X, 400 Y, and 150 Z. No? Again, this number here denotes the expected usage or number of people per day that they're expected to be um, uh, using or maximizing these recreation facilities that they're planning to build. No? All right. Now, there's another constraint on the uh, budget. No. So remember, we only have $120,000 construction budget here. But how much? Let's just consider this as a peso, ha? This is in here, it's stated in peso. No? So 35,000 pesos for a swimming pool. I'm not sure what kind of swimming pool is that for only 35,000. So, and then 10,000 for tennis center, 25,000 for athletic field, and 90,000 for a gymnasium. Again, um, there's a constraint because they only have 120,000 pesos construction budget for all of this. No? So there's really budget constraints. No? Of course, there's also a constraint on the land requirements, no? Because they only have 12 acres of land. But then a swimming pool requires 4, tennis center 2, and then 7 for athletic field, and 3 for a gymnasium. Uh, so we express that as an equation again, equal or less than 12 acres. And then for W and Y, remember in class, W is your swimming pool and Y is your athletic field. Tama ba? Because I think because of swimming pool and tennis center must be built on the same, I think it should be X. No? So Y and X is equal to or less than one facility because it mentioned here, class, that swimming pool and tennis center must be built on the same part of the land parcel. However, only one of these two facilities can be constructed. So we have to choose whether it's a swimming pool or a tennis center. And of course, this is what makes it different from a linear programming. So we have this constraint. No? So W, X, Y, Z is equal to 0 or 1. No? So again, this is very similar to your linear programming. So what I'm going to introduce again to you once again is, alisin ko muna to, is on the use of Microsoft Excel to calculate for the unknown values. No? So in this case, the construction of swimming pool, tennis center, athletic field, or gymnasium. So this is fairly the same table that I presented earlier, but in this case, we have pool, the tennis center, the field, and gymnasium rather. So the daily usage are 300 for swimming pool, 90, 400, and 150 for tennis center, athletic field, gymnasium, respectively. Now, we have constraints on the cost. No? So it will cost us 35,000 to build a swimming pool, 10,000 for a tennis center, 25,000 for athletic field, 90,000 for gymnasium. And then we also have these space requirements. And also the contingency. Contingency basically class, it's saying that we can only build either a swimming pool or a tennis center. No? So in this case, that's also, we also need to express that as a constraint. No? So again, to calculate for, I mean, the formula to derive this would include um, the blank spaces, I mean blank cells here, which will be automatically populated again when we use the solver add-in under your data menu. So we'll also have that later on. Okay. So again, for the usage, we have to multiply this with the X number of swimming pool, tennis center, and athletic field. Again, the constraint is we only have 120,000 pesos as our budget. No? For the space naman, we only have 12 acres of land available. And then for swimming pool and tennis center, we have to decide to build only one of these. No? So we can't build um, those two facilities. No? So we have to choose only one. Okay. So we then need to use, one moment. Okay. So we now click solver and then set objective. Again, our objective will be to maximize the profit. No? So it's here. Maximum, of course, and then by changing variable cells here, so we have to click those cells, and then here what will be our constraints, no? So number one is either in this case class, we can do one by one, or we can simply highlight these three, no? So that it will be captured as constraint. Anyway, the constraints here, the symbols are all the same, no? So uh, it's less than or equal to the values reflected in column I, or in this case, the available resource that we have. No? So that's G7. So from here, G7 to G9 is equal to or greater than I7 to I9. No? So that's the simplest way to do that. Or, listen ko to, or we do one by one. So let's click here and then less than or equal to here. Oops, sorry. So, and then less than or equal to 120,000. Okay, add. And then here, less than or equal to 12, add. And then here, find less than or equal to 1. Okay, so we have these three. No? Uh, like I said, you can do it just like this, or earlier, you can just simply get all the values for column G, for G7 to G9, and then I7 to I9. It will give us the same. Now, for C12 and C15, I mean here, no, for C12 and C15, we have to denote here binary. No? So how are we going to do that? No? So I'll delete it first, no? So just to demonstrate it to you. So we have to click the cell reference, so here, C12 to C15. But instead of putting the symbols less than or equal to, we have to include binary. No? So I. Now, class, the reason why we're putting a binary here, binary here is simply to express it in the base two numeral system. So meaning, class, um, it will give us a number, a whole number, no, instead of dealing with these decimal places. No? That's the basically the essence of it. No? So we hit solve, and then it will now give us the number of oops, sorry, solve. All right. So meaning we have to build one swimming pool and one athletic field to have a maximum daily usage of 700 people. So that's how we solve a 0 to 1 integer model example. So in this case, class, we have 4 facilities that the community council is thinking to build. No? So with the use of solver add-in under your data menu, it basically gives us one swimming pool and one athletic field. So did we maximize everything that we have here? Yes. So while we have remaining money here, it won't be able to accommodate any other facility, no? And then this is the perfect, or I mean, this is the best combination to maximize the number of daily usage. No? So that's 0 to 1 integer model example, integer model of integer programming. Okay. So the next and the final model is so-called the mixed integer model example. So it's a mixed integer model. So let's take this problem as an example. So Nancy Smith has 250,000 pesos to invest in 3 alternative investments. So we have condominiums, land, and municipal bonds. Imagine you only have 250,000 pesos, and yet you're thinking to invest in condominium, in an land, and then meron pang municipal bonds. No? So we'll see. She wants to invest in the alternatives that will result in the greatest return on investment after 1 year. Ayan, class. So um, that's the intention. No? So that's what the problem is telling us. No? So we have to get again the perfect mix, no, on how to invest this 250,000 pesos money of Nancy Smith. No? So it says here, each condo costs 50,000. Ano kayang klaseng condo? And will return a profit of 9,000 pesos if sold at the end of 1 year. Each acre of land costs 12,000 pesos and will return a profit of 1,500 pesos at the end of 1 year. And each municipal bond costs 8,000 and will result in a return of 1,000 if sold at the end of 1 year. In addition, there are only 4 condominiums, 15 acres of land, and 20 municipal bonds available for purchase. Now, before we do the solver add-in, no, let's identify first the uh, constraints. No? Of course, if we're going to express profit maximization, so let Z be the profit. So Z is equals to 9,000x. So remember, no? So the return that we're expecting from purchasing condominium unit, no, and probably leasing it out will be 9,000 pesos at the end of year 1, and then 1,500 for acres of land, and 1,000 pesos for bonds, no, for the municipal bonds. So that's the profit maximization equation. Now it is subject to uh, decision constraints. No? So number one, we only have 250,000 pesos. How much is a condominium unit? That's 50,000. How much for an acre of land? 12,000. And how much for a municipal bond? That's 8,000. Now, aside from the budget constraints, there's also limitation in the number of resource. No, says mentioned here that there's only 4 units of condo available, 15 acres of land available, and uh, 20 bonds, uh, 20 units of bonds available. Now, here's the difference again for the integer programming. So y, or the acres of land, of course, this cannot be expressed in this cannot be expressed in fraction, no? So this is acres of land, so that it could be greater than or equal to 0. No? And then for X and Z, so that's the condominium and the bonds. So we express it as a 0 or a whole number or integer in this case. So what this, I mean, this equation is just telling us that this is a mix, no? It could be 0 or an integer, no? Of course, or we're talking of condo, of land, and then municipal bonds in this case. No? So let's do now the data solver. Okay, so let's proceed directly with the data solver. No? So we've already established all these constraints naman. So let me just delete that first. So we go to solver. Okay. So of course, the objective would be to maximize the profit. So that's max. And then I just included here the cell to denote the profit, no? Because in this cell, oops, in this cell, we're actually calculating what would be the profit, no? If we have the condo, the land, and the municipal bonds purchased, multiplied of course by the respective number, I mean the respective profit at the end of year 1. So it's all given in the problem. Okay, so notice the constraints. No? So number 1, we have B10. So what's B10? So number of bonds is less than or equal to 20. Kasi remember class, it's subject to number of municipal bonds available, no, which is 20. Let me just move this here so we can have a better view of what we're discussing. Because like I said, plus, when we discuss this creation of equation, no? Including the profit maximization and this constraints, no? That's decision constraints. This is essentially what's going to be also filled out in this solver parameters. No? So let's do one by one. So we have B10. B10 is your number of bonds is less than or equal to 20. Kasi nga, there's only 20 uh, number of bonds available. Uh, let's skip that first. No? So that's the constraint number 2. Number 3, B8 is less than or equal to 4. So that's the number of condominium units. And then B9 is less than or equal to 15. So that's the number of acres of land available. Of course, we have a constraints on the budget. So that's F5, amount of money to be invested is equal to or greater is equal to or less than 250,000 or H5. So that's the amount of money that we have. So that's our budget. Now, remember class that we also have this integer, no? So B10, so what's that? B10 is a number of bonds and B8, no? So the condo. So meaning we have to include equals to integer. So meaning it needs to be a whole number. So how to do that. So add. So that's B X, no? So that's B8 is equal to, no? So you have to select integer and then hit add. Okay. So of course you have to pick on the make unconstrained variables, non-negative, and then simplex linear programming, and then hit solve. Okay. So plus in this case, as you can see, it gives us these numbers. No? So for condominiums and bonds, of course, like I said earlier, it cannot be a fraction of a number. No? It has to be whole number. But in land, it can be portion, no? Kasi I mean in land it's really a measurement, no? So we can actually proportion it, no? So uh, it can be less than one, no? Less than a whole number. So in this case, 0.17 acres of land. No? So to maximize the profit, it's said here that we need to purchase 4 condominium units, 0.17 acres of land, and 6 municipal bonds. No? So it will maximize the profit of 42,250 pesos. And as you can see, all of our money was also fully invested. No? So this is very good in terms of maximizing the use of our surplus funds or excess funds. No? So again, in a mixed integer model, it's a combination of integer and non-integer. So in this case, the integer values would be the condominium units and the bonds, no? And the non-integer would be the land, no? Especially that land, like I said, can be a portion, no? So it can be just a fraction of a measurement. So let me just check this one more. Okay. So let's just check whether we've satisfied all the learning objectives, no, for this session. So we have a bit of a review of the principles of linear programming. So like I said, class, integer programming is similar to your linear programming. So if you feel like you need to go back to our previous recording on linear programming, please do so. Like I said, the whole integer programming, the basic of it follows the linear programming concept. No? So we also defined an integer. We have demonstrated the use of Microsoft Excel, specifically the solver add-in option under your data menu tab. So well, I encourage you to do is what I'd like you to do is um, also check on your Microsoft Excel and then see if you can reperform the whole uh, process that we've discussed this session. So of course, you can only say learn that by number one, checking on the video discussion and then trying to do it yourself. No? So we have illustrated the three basic types of integer programming. So we have the total integer, 0 to 1 integer, and the mixed integer models. No? So um, and that's it for the integer programming. If you have any questions, please send me a message on my email. You can also send a message through Viber. And that's it for today. And thank you for your time. So stay safe, everyone. Goodbye.